So we have pushed our training container to container registry. Now we need to actually trigger the training so that we can train and tune the model. Let's see how we can do that. In the previous section, we wrote the train.py and Docker file, and we learned how to package all our training code, and now that it needs to be known and available to train our model, into that little Docker container. We also saw how to push it to container registry. Now, we will learn how to retrieve that image from the registry so we can train and tune our model at scale using AI platform. We can execute our trainer package locally. After we ensure everything is working, we use the gcloud command to submit the training job to AI platform. To train in the cloud, we run the command gcloud AI platform jobs submit training and choose a job name. This command has two main parts. First, you need to provide the URI of the container image. The URI should be exactly what you defined when you were building and pushing the container with gcloud builds submit. Then you need to provide a path to the config.yaml file, which contains the information about which hyperparameters to tune and which range of values to try for each of them. Note the scale tier option here. There are more details in the documentation, but you can choose from predefined tiers or create your custom tier. Basic, for example, uses a N1 standard for virtual machine. You can also choose a virtual machine image with support for accelerators, such as GPUs and TPUs. You can set additional parameters when triggering a cloud training job, such as the path to the training and validation datasets, and whether you want to use hyperparameter tuning. You can check the documentation for more details. Okay, after you launch that command from the Jupyter Lab, training will start. After the training job is complete, the console will display the various runs with both the hyperparameters and performance metrics. You will see the different trials or runs of the training with the different parameters that have been trained along with the target metric. In this example, we find the accuracy for different values of the max number of iterations, for example, 200, 500, and again 200, 500, tried with different values of alpha. If you click on the job from the list, you see more information about the particular job. The best model from the training job will be the first one on the list of hypertuned trials, because the trials are sorted in descending order of the metric chosen. In this case, the best accuracy will be at the top. For this example, the best model was trained with a max iteration of 500 and a value for alpha of 0.00028. These achieved the best accuracy of 70.2, given the number of trials, of course. Now that we know what the best values for the hyperparameters that we tuned are, our goal is to train the model with these hyperparameter values, save the model, and deploy it to start getting predictions. There are two ways to do that. We can just look at the values on the console and enter them manually when starting a new training job, or we can do that programmatically. In the lab, we'll be doing it programmatically, so let's look at that. To retrieve the best parameter values, use the Google API client, as shown here. This example uses the API client to retrieve the best value for the hyperparameters alpha and max iter from the first trial. Remember that the first trial, trial number 0, is the best one. So we look at the first trial and retrieve the corresponding values for the hyperparameters. After we retrieve the best values for the hyperparameters we need, we should use them to retrain the model, save it, and deploy it. To retrain with the best set of parameters, use the same command as you did for the training and tuning phase, but this time, make sure you omit the config argument. Instead, you will pass the actual best parameter values through the command line after the / argument. Remember to also set no HP tune so that when the code is executed, HP tune is set to false. The trained model will then be saved to cloud storage at the end of the run. Remember that in train.py, we had a conditional statement looking at the HP tune value to decide whether to pickle the model and export the model to cloud storage. Here, we'll execute the code that does that when HP tune is equal to false.